Today, we are going to tackle about stem cell therapy, the regenerative medicine. So, before I go to the main point of my topic, let me require you to imagine. Imagine the two people are listening to music. And what are the odds that they are listening to the exact same playlist? After all, we have different tastes in music. Now, what are the odds that your body will need the exact same medical care or treatment as another person's body? Even lower. As we go through our lives, each of us will have different needs for medical care or treatment. That's why our scientists and doctors constantly researching ways to make medicine more personalized. Before I go to my main point of this topic, let me look at this. The natural organization is made up of cells, self-regulating and semi-autonomous. When the group of cells combine with another group of cells, it will form tissues. And when the tissues combine with another tissues, it will form an organ. And when the group of organs combine with another group of organs, it is called organ system. And the organ system coalesces to form humans or organisms that ultimately live in the environment. You know, what's nice about this hierarchical scheme is that it builds an upward scheme rather than downwards. Is that it allows us to think about illnesses as well in a somewhat different way. Okay, take an example. Take a disease like cancer. Since 1950s, we tried to kill these cancer cells through the variety of chemotherapies or targeted therapies. And as most of us know, that it's worked. It worked for leukemias and also worked for other forms of breast cancers. Now, let's go to our main point. What are stem cells? Stem cells are cells that have the potential to develop into many different kinds of cells. Stem cells can be thought of primitive and specialized cells that are able to divide to become a specific type of cell in the body, such as liver cells, muscle cells, blood cells, and other cells with specific functions. Stem cells can be referred to as undifferentiated cells because they have not yet committed to a developmental path that will form a specific tissue or organs. And the process of changing into a specific type of cell is called differentiation process. And you might ask where the stem cells came from. Stem cells came from the bone marrow. And the bone marrow is one of its responsibilities is to produce a stem cell that will become a specific type of cell in our body for regeneration of tissues. So as you can see, this is the stages of development of this stem cell. So from unicellular up to multicellular, and that will develop a blastocyst or an immature cell. So there are three kinds of different types of stem cells. One is the embryonic stem cell, two is the adult, and third is the induced pluripotent stem cell. First, we go to the stages of the embryonic stem cell. So typically, the embryonic stem cells came from the leftover embryos that are willingly donated by the patient from the fertility clinic. The embryonic stem cells are pluripotent. It means that they can be grown into many different kinds of cells. And these are the three regions of the embryo that give rise to the specific organ system. The ectoderm is the outer layer, the endoderm is the innermost layer, and the mesoderm is the in-between of the two layers that generates the blood, heart, kidneys, gonads, bones, and connective tissues. Now let's go to the adult stem cell, or so-called tissue-specific stem cells. These cells are found in small numbers in our body's tissues. These stem cells replace the existing cells that, that, that in short, they divide and replenish dying cells and regenerate the damaged tissues. So the third one is the induced pluripotent cells. These are regular fat, liver, or other cells that scientists have changed to behave like embryonic stem cells. Like embryonic stem cells, they can become any kind of cells in our body. So what are the stem cell therapy? Stem cell therapy can be used to generate healthy and functioning specialized cells which can be replaced diseased or dysfunctional cells. It is similar to the process of organ transplantation, but only the treatment consists of transplanting cells instead of organs. So you might ask, what diseases can be cured by stem cell therapies? So any disease in which there is a tissue degeneration can be a potential candidate for stem cell therapies. And these are the lists that stem cells therapy can be applied, like in Alzheimer's disease, Parkinson's disease, spinal cord injury, heart disease, severe burns, and diabetes, and etc. The knowledge we have right now, including the information in this presentation, is subject to change. Why? Because science is always evaluating the existing body of knowledge and filling the gaps. And as you can see, the stem cell field is still in its infancy. And human embryonic stem cell research is a decade old. Adult stem cell research has 30-year head start. And you know, because researchers and our doctors constantly researching ways to make our medicine more personalized. That's why they search about stem cells. Stem cell therapies can help us to make our society meet the 100% healthcare services available for humankind. And the scientific inquiry and the need for advanced medical technology guides the questions the researcher asks, and we can predict exactly where the stem cell field is going and what cures may or may not exist 10 years from now. But we do hope that the stem cell therapy, the regenerative medicine, holds hope for curing or improving treatments that will ensure the 100% healthcare services available for humankind here in our society. Thank you.